We will now discuss the solution of a problem from the section differential equations. The problem is related to a given initial value problem. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is, let the solution curve of the differential equation x dy by dx minus y is equal to under the square root of y square plus 16x square. Y when x is equal to 1 is given to be 3, b y is equal to y of x. Then y when x is equal to 2 is equal to, we are given 4 options. Option A 15, option B 11, option C 13, option D 17. We are given a differential equation with an initial condition, the value of y when x is equal to 1 to be 3. This differential equation, under this initial condition, the solution of this differential equation under this condition is y is equal to y of x, and that is the solution curve of the differential equation. Required to find the value of y when x is equal to 2. We now discuss the solution of the problem in detail. This is the given differential equation with the initial condition y when x is equal to 1 is given to be 3. It is an initial value problem. Why this is called an initial value problem? Any differential equation along with a given initial condition is called an initial value problem. Now take the differential equation and now send minus y to the right hand side, that will be plus y. Then divide by x. Then we get dy by dx is equal to under the square root of y square plus 16x square plus y by x. Now this is a rational function. The numerator is a function of x and y, and it is a homogeneous function of degree 1. The denominator x is a homogeneous function of degree 1, and the numerator by denominator is a homogeneous function of degree 0. So dy by dx is equal to f of x comma y, which is a homogeneous function of degree 0. Then it is called a homogeneous differential equation, and the method, we know the method. The method is put y is equal to vx, where v is a function of x. Now differentiating, we will get dy by dx is equal to v plus x dv by dx. Apply the product rule. Now substitute in the given differential equation. So take the differential equation, substitute dy by dx is equal to v plus x dv by dx, the left hand side, is equal to under the square root of y square is v square x square plus 16x square plus y is vx by x. Now in the numerator, under the square root of x square under the square root of x square, that will come out and come out as x, and x and vx is also there. In the numerator x is common, the denominator x is available, so cancelling we will get v, the left hand side is v plus x dv by dx is equal to under the square root of v square plus 16 plus v after the cancellation. Now v appears on both sides, cancelling we get x dv by dx is equal to under the square root of v square plus 16. Now we can separate the variables. So that is, we apply the method of solving the differential equation by variables separables method. So separating the variables and integrating, we get dv by under the square root of v square plus 16 integral of dv by under the square root of v square plus 16 is equal to dx by x integral of dx by x plus c prime, where c prime is an arbitrary constant, and integral dv by under the square root of v square plus 16 is one of the most standard integrals what we have learnt in our plus 2 level. So let's recall the integral of 1 by under the square root of x square plus a square with respect to x is equal to log to the base e of mod of x plus under the square root of x square plus a square plus c. So apply this, we will get ln of mod of v plus under the square root of v square plus 16 is equal to ln of mod x plus this c prime we have written as log ln c, where ln c is c prime. Agreed. So ln mod x plus ln c is ln of c times mod x, taking the logarithms out. So this will imply v plus under the square root of v square plus 16 is equal to cx. Taking off the logarithms on both sides, we get this one. Agreed. So now what is v? Y is equal to vx. Therefore v is equal to y by x. So substitute for v y by x. So v is y by x plus under the square root of v square y by x whole square plus 16 is equal to cx. Now take the LCM. So the LCM is the x, that will be y plus under the square root of y square plus 16x square is equal to cx into x, that is cx square. And this is the general solution of the given differential equation. We have not applied the initial condition yet. So this is called the general solution because it contains one arbitrary constant. See, it contains as many arbitrary constants as the order of the differential equation. Therefore, this is called a general solution. So we move to the next slide for evaluating the arbitrary constant C. So we are given the initial condition. We apply that in the general solution. So given y when x is equal to 1 is equal to 3. That means put y is equal to 3 and x is equal to 1 in the above general solution. We get y is 3 plus under the square root of y square is 3 square, that is 9, plus 16 into x square is 1. So 16 is equal to c into 1, that is c. So solving, we get c is equal to 8. Substituting c is equal to 8 in the general solution, we get the particular solution, that is y plus under the square root of y square plus 16x square is equal to 8x square is the particular solution, and this is the solution of the given initial value problem, given differential equation under the initial condition. And this is the solution curve, that is what is given the solutions. That means y is equal to y of x is the solution curve of this initial value problem. Now required to find the y when x is equal to 2, that is find y when x is equal to 2. So in the above equation, substitute x is equal to 2 and solve for y, and that will be precisely the value of y when x is equal to 2. So y plus under the square root of y square plus 16 into x square is 2 square is equal to 8 into x square is 2 square. So this is 8 into 4, 32. This is y minus 32 is equal to minus under the square root of y square plus 64. Squaring on both sides, we will get y minus 32 whole square is equal to y square plus 64. Now take the square. squaring the y minus 32 whole square is y square minus 64y plus the 32 square is 1024 is equal to y square plus 64. Cancelling y square on both sides, we get 64y is equal to 960. From this, y is equal to 960 by 64, that is 15. And that is the value of y when x is equal to 2. So there this will imply value of y when x is equal to 2 is 15. 15 is because of 960 by 64. Let's look at our options. Our answer y when x is equal to 2 is 15 appears against option A. Therefore, the answer to this question is option A. That is the detailed discussion of the solution of the problem from the section differential equations, which is based on the concept of initial value problem and its solution. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.